In this project, I explored decision tree classifiers for escape room business. The basic motivation for this was that my friends have an escape room business that's currently growing with several different rooms, varying difficulty levels, locations, and themes. And I'm the person who constantly answers questions about suggestions through email. So there's this giant need for a recommendation engine based on answers to certain questions. So one of the potential solutions was to create a decision tree classifiers, which is a form of a supervised learning algorithm. It's a great choice for recommendation engines. It's very intuitive and easy to build. So I created a training data that were answers to these 5 different questions. I go more into detail about this in my Jupyter notebook. I used one-hot encoding, which was the idea to encode data that was not numerical because I needed to do so for the classifiers I used through Python. And the idea for that was that I did so to prevent any kind of encoded relationship between the data that I was trying to encode. For example, the relationship between themes, there is none, so I wanted to prevent that. So I used the sklearn Python library to make different classifiers with different methods. I explored the difference for the different splitting decision criteria, which is the Gini index and entropy. I go into more details about it in my Jupyter notebook. I looked at how different they are in terms of categorizing feature importance. So for one of the methods, some features were more important than for the others, although overall on the training data set they performed exactly the same. And when I input this data above, they gave me a suggestion for exactly the same room. But when I try to visualize this data with the graph viz, I could see that even from the very beginning they're kind of looking at they're splitting on a very different question, so the tree structure ends up being very different. I tested on random data with 25 samples that I had to decode into meaningful information and then encode back with into numerical information. And here's the probability of each of the 7 classes that I get with either of the 2 classifier methods. When I looked at the accuracy with label test data, we can see the sudden drop between the accuracy with the training data and the testing data. But again, overall, Gini and entropy methods perform exactly the same on exactly the same data. I also explored the difference in class weights, how it affects the feature importance distribution for the 2 methods. I also applied it to this 25 samples of random data and saw the results above. And when I looked at the accuracy between the balanced and unbalanced version of the 2, again, there was no difference. I also tried to constrain tree size to kind of avoid this overfitting effect. And I fine-tuned a few parameters with the tree size constraint that you can see above, and I go into more details about it in my Jupyter notebook. I also use random forest, which is another way to improve accuracy of the decision tree classifier, and I explored one of the parameter tuning for it as well. And then lastly, I looked into gradient boosting machines and explored how I can fine-tune the accuracy by fine-tuning a few of the parameters, such as different learning rates and different number of estimators within the gradient boosting machines. Lastly, I created this input GUI where the person could input their own answers to the 5 questions, and then the engine would give you that it is some percent certain that you should play one specific room. And then some of the issues I've had during this project was generated training data and labeling testing data, which I go again into more details in my Jupyter notebook, and some of the future work that I hope to explore with this project, even after the class has ended, is to explore multi-input data classifiers where the user would be able to input more than one answer for the same question, and then looking into different encoding methods that would actually encode a more meaningful information about the different answers that would actually kind of like point at the certain relationship that there are between the two.